It's my pleasure to welcome you all here tonight for Vizzuality's first mini event, and we're focusing on climate because it's an important issue to us, and it's also important to many of the speakers that we've spoken to throughout the course of the years, and it's always been our intention, I think, as a company, and I can speak for not only myself but my co-conspirators, many of whom are in the room, and we've been talking about how we can make Vizzualized have more impact in the community and in specific communities, and we want to take on some of the issues that are important to us. So this is a very heartfelt kind of event that we hope we can do more of at a much larger scale, and we thought it would be the perfect way to kick off the big event that we have coming up for the next 2 days, which is Vizzualized 2014, taking place once again at the Time Center. I want to give a warm round of applause for our speakers who are here tonight. Thank you. Thank you so much for braving the snow and making it out here and taking part in this very special, intimate event. And we wanted to keep it small, not just because we wanted to make it special for the people that are here in the audience and give you a chance to interact with some of the speakers that are here, but also because this is it's something that is so close to us that we felt like we wanted to have just the closest people to us here. So thank you again for coming out. We're super excited for tomorrow. I'd also like to thank Katie Fehrenbacher, my girlfriend, who has been instrumental in actually making this happen. This is an idea that she actually had quite some time ago, and it's something that we've been wanting to do for a long time, along with, again, my co-conspirators at Culture Pilot, who are somewhere up there. And so with that, let me just get to some important other thank yous here. This wouldn't be possible if it wasn't for the SVA and the SVA Theater, where we're at right now, and even more specifically, I want to thank Joan McCabe and Nathan Fox from the Visual Narrative program. It's they've been very good supporters of Vizzualized for quite some time, and we've been talking for a couple years, I feel like, at least a year and a half, about their new program. Once again, it's the MFA Visual Narrative program, and that's it right there. It's a story visualized, so obviously there's a lot in common between what they're doing and what Vizzualized is doing. And once again, they were the ones that allowed us to be here tonight. So thank you to SVA, the theater, and the Visual Narrative program. And really quickly, I also want to thank our sponsors for the main event. We've got some awesome ones here. I'm going to say this now, and I'm going to say it again tomorrow. One of the things that I think is exceptional about our sponsors is that we don't have a sales team. In fact, nobody working at Vizzualized does this full time. So these are people that generally have come to us. So we think they're highly intelligent, and we appreciate their business. And so with that, let me just talk a little bit about what's going on tonight. We've got a few presentations from people that are very well respected in the community in terms of studying climate change, both on the academic side and on the visualization side, and there's definitely crossover between, and we're starting to see more and more of that, which I think that would be a reason why we can do this on a much larger scale pretty soon down the road. And our speakers, Javier de la Torre, awesome person. Javier, super happy to have you here. I know you just got off a plane, so very impressive. He's actually not going to be presenting tonight, but he is going to be taking part in the panel that's following the presentations. But speaking on behalf of CartoDB and Vizzuality is going to be Andrew Hill. And then we've got Marco Tedesco, who's also here right in the front row, who has got a cast on his leg and managed to walk through the snow. So we've got some real troopers here. Gavin Schmidt's also going to be doing a presentation, and he's from NASA Goddard, so we're super excited to have him. And then after the presentations, we're going to have people come up on stage, and we're going to have a quick panel discussion moderated by our good friend, DJ Spooky, also known as Paul Miller. And he has a very extensive resume, but he's very in tune with, he's an environmentalist by heart, and very in tune with what's happening with climate change, having gone on tour with Bill McKibben and having a large focus on this. And I think the only person I know that's ever been to Antarctica. So please give another round of applause for our speakers. With that, I want to introduce one more person, and it's my good friend Nathan Fox, who is the chair of the MFA program, the Visual Narrative at SVA.
Well, thank you guys for having me and the opportunity to do this. This is a great opportunity as chair of a graduate program in visual storytelling. I am personally an illustrator and a comic book artist, and I am a huge fan of information and data visualization. I thought I had a crack habit, but all of you people are insane. So to be able to incorporate this within the program, because we are interdisciplinary, is amazing. So thank you, Eric, and everybody else here who put this together. Growing up, I was a rabid consumer of everything NASA, topographic maps, you name it. I was really consuming it. Girls and Legos and all that other stuff was great, but if it came in graphics or you could dissect it, I was all in. So the idea that those worlds were tangible and real, really kind of excelled my imagination, and really kind of perpetuated the awesomely twisted visual path I lead today, and everything that we incorporate within the program that relates to graphics and storytelling. So it is beyond a pleasure, I can't say it enough, to be here and to be able to support Visualize. So without further delay, let's get to our first storyteller. Andrew Hill, please.
Hi, everybody. I had no casts or flights between me and here, so I'm really excited to be here, and I'm really excited to talk to you. So I'm going to talk to you a little bit about something tangential to climate science, and especially visualization and climate science, and try to hit on it a bunch in my talk, and why the things I'm talking about are important to it. I'm from a company called Vizzuality. We work on a lot of things. I guess to put them in some bins, we work on issues of data communication for science and conservation. We've worked a lot on citizen science and building applications to bring people to building data for scientists to use. We've put events together to bring people to the problems that are important to us with the environment and the world and try to come up with solutions in the same room. And then today I'm going to talk to you about the subject of the meeting, but I decided to put some periods between it. I'm going to talk about data, visualization, and a little bit about climate change. And I think the rest of the panelists are far better experts at climate change than I am. But I guess the thing I want to get across is that right now for data visualization for climate scientists, we're kind of here. And that is that a lot of the people that are making visualizations can be put into the category of masters. What we really want to get to is here, where everybody has the tools that are easy enough for them to use and familiar enough for them to use, that they can look at climate science, understand it enough to make their own visualization and come up with the right conclusions about what's going on. And we think that will get science a lot further, a lot faster, and people will have much better conversations about what's changing in the world around us. So I wanted to kick into that argument and start talking about that seeing is believing, that visualizing data is a powerful thing. I don't think anybody in this room is going to argue against that. For us at Vizzuality, a lot of that has started with maps. And we've come to really understand this idea that maps are a great tool for data visualization and for visual storytelling because people get maps. You get really annoyed by that guy walking down the subway in front of you because he's staring at his map to get around. People are really comfortable getting into maps. And that has a long history, longer than this, but a really good example of it is that every morning for years, people have brought the daily weather report to you in your living room. And nobody gets worried about that. Nobody feels uncomfortable approaching data and data visualization on a map like this, even though the weather report can be quite complex. And so that gets me to my first visualization from climate science. And so here's a really great visualization that NASA put out. And I understand it, and I get it, and I think it's really beautiful, and it tells me a lot about the world around you. And everybody here in the audience can look at it and probably get a lot of the same conclusions I can, and feel really moved by seeing something like this about how the world is changing and what's important. But the thing is, communicating science for scientists and for the map nerds and for visualization nerds is different than communicating science for the other people, for the people that we really need to communicate a lot of times. And so this was an article where this visualization was posted, and this was the writer summarizing it at the very end in a quick quote. And I'm not saying that that visualization is bad. I really actually love that visualization. But sometimes we need to be careful about how we let people draw their conclusions from the visualizations, because sometimes it's very easy to brush off the seriousness of climate change. So I wanted to show you a couple good examples that I like. From the New York Times, here was an article that was covering the effect of climate change on the water level. And what I really like is that instead of showing you the global problem, instead of showing you issues that they saw as issues, they really let you drill down into the areas that you know about. What are the coastlines that you know about in the world? And how is the water level change going to affect you and the places you know? Contextualizing the problem in data visualization is really helpful for giving the right story. Here's another map that I really love that does a similar thing, and it's not talking about climate change, but it's talking about the problem of Syrian refugees and what the scale of that problem really is, and visualizing where we actually could, where 1 million refugees could actually be placed. The importance of story is that it frames visualization. And so we really think a lot at Vizzuality about how we can merge those two things, narrative and story, into the same thing, so that we can get people to valuable conclusions. Here's a project that we work on, and actually this visualization, I think, fits in the same category as that first NASA visualization. Here we're showing the effect of deforestation over 6 or 7 years. And each of the pixels that turns pink is a pixel that deforestation has been detected by algorithms. So this is really compelling to me, and as a map nerd, I get really interested in it, and I go, wow, I can visualize deforestation just like that in front of me, and I can see the impact it's having and how widespread it is in this area. But at the same time, it can be difficult to release this to just anybody and say, okay, you should be able to draw the right conclusions about it. So what we try to do a lot on top of this is try to frame the complex in a story. So here's a story that you can get from those same pink pixels. So if you look at it, there's this sort of discolored blob in the middle, and that's a protected area. And if we watch the same visualization over 3 years, we see that the pink starts to spread into the protected area. And so the story really isn't that just deforestation is happening, but it's why is deforestation happening suddenly in this protected area? Because that's probably important to a lot of people. And so we look further into the map, and we see this same pink blob, and we see this blotch on the map. And we got curious about what this blotch on the map was, and we zoomed in a bit further, and we dug into what this story was, and it turns out that it was a dam. And then when they built this dam, over the course of the next 3 years, it displaced all this forest. And so deforestation actually happened because humans had built a dam that flooded a valley. And so this is an interesting story that you can get people to realize actually how deforestation is happening in a lot of places and how widespread it can be. And they can understand the scale of a dam and the scale of a valley and understand this problem in different ways. And so then we started wondering, how can we turn everybody into storytellers like this? We wanted to turn our audience into collaborators and not just give you a map and find the dam for you, but find ways for you to do it. So for quite a while, we've been working in the area of citizen science, like I said. Here's a project I wanted to highlight. It's called Old Weather. It came out a few years ago. And the idea basically is to help digitize ship logs from 100 years ago. So ships traveling all around the world, and the captains kept fairly detailed logs about where they were, what the temperature was, what the pressure was, wind direction, all these different variables. But they were locked up in handwriting in these sheets of paper in museums. And so we helped build the interfaces so people could extract that data in a way that then scientists could use it. In a year and a half, we got a million of these records transcribed. And we were able to see these ships moving around 100 years ago. So here's a map that we made a while back of these ships moving around. That's pretty cool. So we're seeing ships move around the world. And that's one story you can get from it. The other story is that the scientists then took the climate data and are building a climate model from this data that was generated 100 years ago. So now this project has closer to 2 million observations and counting. It's still going. And at Vizzuality, we thought about this, and we thought about how citizen science could really change the way people tell stories with data, and how data visualization could happen, and how mapping could happen. And we thought more about how we could turn audience members into creators. So we thought we could build tools for anybody to start doing these sorts of things. We built our first tool to start doing this. It's called CartoDB, and we like to say that it democratizes mapping online. It's meant to turn anybody into an expert map maker really quick. And so I want to show you a couple highlights of some of the users. These are the contour lines of Iceland. This is a way I've never seen contour lines in the elevation of Iceland or any place ever before. I really love this map. This is a map made for the city of Melbourne. It maps every tree in the city. You can see some symbology to show the species and when their last maintenance was, how old the tree is. I also love that you can click a tree and it says, email this tree. It's my favorite part. Here was a project that was done to track seagulls. And so they put GPS units on a bunch of seagulls and they track the movement. So this is one seagull, his name's Eric. And this is his movement over the course of a year. You can see that the more green the lines are, the earlier in the year. The more red the lines are, the later in the year. And I can tell you that somewhere in there, he had a nest that he was really curious about. And so he started had a nest that he was very concerned about, so he started staying closer to home. And so you can start seeing these things in the map really quickly. And we're not making these for people anymore. People are making these themselves. And so that leads me to my last thing, is how do we get more people to be able to make interesting visualizations of scientific data? And so my last argument is open data, and it leads to interesting projects, it leads to interesting insights, and I think most importantly, it builds communities around these problems. And so I wanted to give a little example of some people that are building maps with open data. So Chicago is the third largest city in the country, and it gets a ton of snow every year. I don't know about a ton if you're from the Northeast, but it gets snow 27 days a year. It's something like 38 or 40 inches a year on average, and it really blankets the city. And when snow blankets a city, it really slows the city down, so you get these plow trucks everywhere. And whenever there are plow trucks, there's a lot of people behind them that are getting annoyed and waiting to get wherever they need to be. And if they're not there being annoyed, they're in their house waiting for their car to get out. And so people get really interested in weather. And there's a lot of reasons why people get interested in the weather. And I heard this first from a journalist friend of mine, and I was picking his brain a bit more. And he said, actually, there's another reason why you see a lot of people interested in weather on the media, and that's because they're sitting at home and they don't have nothing else to do besides watch the weather on the media. But let's ignore that for a second, and we'll say people are really interested in the weather. And I think it has to do a lot with this because it actually influences their life. And so, really interesting, Chicago makes the data from all those plow trucks available for everybody to get. And some hackers got together and put together this project called Clear Streets. They take the data, they standardize it, they make it available. So every time there's a snowstorm, you can go and look at their maps, and you can see how soon the plows, or how recently the plows have been on your street, if they've been there at all. And so you can start to gauge how soon they'll come to your neighborhood and how soon you'll be able to get to the places that you want to go. Here's a visualization of that data over a single snowstorm. And just by looking at this visualization and the plows moving over the city, you can start to get some insights of how they work over the course of a snowstorm. But this is the one I like a little bit more. And you can see how they build and they grow across the main corridors, and then they start to fill in to the smaller neighborhoods. So I started wondering, is there actually some logic behind that? Are they doing something special to pick the way that they're doing this? And I asked the guy behind Clear Streets if he knew. And he said, well, actually, all they do, and he'd asked them, he said all they do is they stay on the main roads until it stops snowing, and then they move into the smaller roads. So it's not very planned, it's not very coordinated. And so then I was wondering, is this actually connected to climate change? Are there ways that I can draw a parallel from plows to climate change in open data? So I wanted to bring in this example. In Centennial, Colorado, which is only the 273rd largest city in the country, they hired a company to come and look at their plow data, which is not open. And they came up with a better plan for them to do their plowing every day. And so they picked a route, they gave them a route that optimizes the way they move around the city. And they were able to make 50% reductions in the number of people that had to work, the number of plows, the number of hours it took them, the number of miles they drove, and I guess most importantly today is the amount of CO2 emissions. And so I started wondering, could we do this with open data? Could we do this with all the cities of the country? There are over 50 cities that have had more than 20 inches of snow already this year. So you start thinking about scaling all the plows, just all the plows in New York, and wondering what sort of impact it would be if we had access to that data and we could make some of these examinations, I guess. And to me, that's really exciting, and that's the power of open data. And today we're starting to get access to that in some cities like Chicago, but what about all cities? What about other categories of data? What about the things that are really important to the topics that we'll be talking about more today? And so I really wanted to make this argument that turning the audience into the collaborator and the collaborator into the creator is something that we can do, and it's really important right now. And I wanted to let you know, I wanted to kind of leave it with what the future of data visualization for climate science is. And my argument today was that it's less and less going to be coming from climate scientists themselves, and it's more and more going to be a growing community of creators. And we can do that with open data. We can do that with data visualization and experts or creators that are able to use the tools that we give them. That's all I had for you.
Thank you very much. Thanks, Andrew. Before I introduce the next speaker, I'm going to actually introduce myself. I don't think that I did that, which is hilarious because I did the same exact thing when I kicked off the Visualized conference in 2012. My name is Eric Close, and I'm the founder of Visualized. I'm busy thinking about all the people in the room, and so I actually thought to myself, I should probably make a slide that says introduce yourself, and I think tomorrow I will actually do that. So the other thing I wanted to say really quick before I introduce the next person is that I also didn't thank Nikki, who has been incredibly important in the fabric of putting this all together. There are a million details. I can't remember to introduce myself. I do not know how she remembers to do a million things, but she gets it done, and she does it very, very well. So thank you very much, Nikki. So with that, Marco Tedesco, please come on up. There you are. And thank you for joining us.
Thank you. Okay. Thank you. Thanks, everybody. Thanks for having me here. I'm the scientist before Gavin. He's the climate scientist. I'm a cryosphere person. So what I do, I study snow and ice. I'll come back to this for a second. My home college is City College here in New York, and I'm currently working for the National Science Foundation, managing a program called Polar Cyber Infrastructure, and he has to do a lot with visualization of data within the polar regions. What I'm going to tell you is a story, really. I hope, to be able to tell it in 20 minutes or less than what I have. So the cryosphere is really the part of the Earth where water is frozen, either permanently, like ice sheets you see over there, or maybe snow like this. New York City becomes part of the cryosphere, or, for instance, this is a scene from New York City over one of the past days. But also cryosphere is sea ice, for instance, the water, the frozen part of the ocean. You also have ice sheets. This is a view from the Greenland ice sheet where the Jakobsand Glacier is basically coming from the top left, and then you have the glaciers coming down to the ocean and then basically calving into icebergs that are, you see here over the west coast of Greenland. Why do we study? What's the connection between the cryosphere and the climate, really? And I'm treating you as my class for the first 5 minutes because I didn't know what kind of audience is going to be sitting here. So there are very important connections. First of all, of course, the impact of CO2 sea level rise from the melting ice from Greenland, for example. You do also have a lot of importance. The snow plays a crucial role, not only because it gets cities stuck, or myself taking like an hour and a half to come from the Upper West Side to here, but also because you do have the meltwater produces a lot of drinkable water for many areas, all the Colorado area, all the Indusku and the Tibetan Plateau. They rely on the melting of the snow for their water resources. Of course, there's a lot of connection with the ocean. It's part of a system. Everything is connected, and the cryosphere plays this huge, huge role. You also do have a lot of impact on the clouds, on the ocean. So it's really, you cannot separate our Earth and the climate from the cryosphere. So what I'm going to focus today is one thing that I am really very close to. And it's a project that we had at City College, my home institution. City College, we had, unfortunately in the past, I have to say, we had an internal funding mechanism through which people and faculty from different disciplines could get together and start to work on interdisciplinary project. The funding mechanism was called City Seeds because the idea was to create a seed for the collaboration that could then blossom in something bigger. And we got one of the awards, and we called this award, of course, Polar Seeds. So the idea of Polar Seeds was really to communicate the processes and what's happening in Greenland through visualization and sonification. And despite, differently from what my current projects are, and the final report is not one of 250 pages of numbers and plots, the final report was an exhibit. So I teamed up with somebody from the music department and somebody from the art department, media professors, and we created the Polar Seed team, and we had also 8 students involved, one of them also sitting here in the audience. And so the exhibit looked something like that. So we had, well, it should look something like that. Okay, so we had basically a series of videos, infographics, and photography together with a video game that you can play on the web, and together with sonification and soundscapes, all in the same area. So the environment was really flooded by soundscapes and sonifications, and people were, this is like the making of the exhibit. And then we had 2 walls dedicated to pictures, to photographs, 2 walls dedicated to infographics, and a wall dedicated to video and a video game. And people also had stands where they could listen to different sonifications. And all the data that we used came from the Greenland model that predicts melting or describes the melting of the Greenland ice sheet and all the processes like albedo, and I will introduce to you what it means, and other things like rain or clouds and so on. So the idea behind the project was not only to really communicate something about what is really happening, like a visualization of the regular data, but the idea was also to try to communicate processes. For instance, this is one of the infographics that one of the students put together, and it really depicts the sea level rise in different scenarios from different climate model scenarios. One other thing that we also created as infographic was the 2012 melting year was what we call the Goliath melting year. And the reason why we call it like that is because basically I thought if you walk in Times Square and you consider the average height of the people around there, then you can basically think about 2012 with respect to the other years as somebody who is basically 2.5 meters tall compared to the rest of the people. That's how strong was melting in 2012 over Greenland. And so we created these infographics where you really see the 2012 highlighting over at the end of the time series that we had then. You also had, see the big melting that occurred in 2012 that covered the entire ice sheet, in 97% of the ice. Even though not all was gone away, like somebody in the elevator was telling me one day. And also you do have photographs, like we were having big print photographs that are describing the processes that we observe. Some of you, Eric, actually I'm the second person that you know is going to Antarctica after DJ Miller. So I go there almost every year, and I spent 5 years in a row in my summer house in Greenland camping on the ice for the past 5 years. So this is one of the, it's not Ardwell actually, this is one of the lakes that drain through the bottom of the ice, and it creates this hole because of the power of the water that is it's basically roaring down the ice, and it enlarges this structure. But also you will see these beautiful structures. One thing I wanted to really talk to you was, I'm not a data visualization person myself, but I really think that these pictures have some aesthetics and also can communicate the processes that we're studying. For instance, in this case, you will see the big canyon that is being excavated by the flow of the water on the surface. And you see the big hole right in the middle, that's called a moulin. It's almost the same thing you were seeing before, but from an aerial perspective. And you see also the crevasse filled, the cracks in the ice. That tells you that the ice is actually moving, is not steady, but it flows like, you can imagine as a lava that is flowing, and it accelerates and slows down and creates these cracks. And this is all part of the same process. You also see this is a stitched photograph that we took from the helicopter, and it really tells you the story about the surface ice sheet hydrology. It looks really like a river on land, but we really know very little about the processes and everything. But still, I do believe it has some very interesting and amazing aesthetic to, in terms of shapes and structure. And on purpose, I took off the perspective, so you don't know what the size really of this thing is. So you have these other patterns here that you will see over the ice. Beside the colors is really a driving mechanism and a driving. What are the processes driving this? This other pattern, for instance, is also extremely powering to me. Superglacial lakes, and of course, this is an iconographical picture of the water flowing from the surface to the moorland. So I was mentioning, for instance, the albedo. And one thing that we wanted to do in our project was really to communicate albedo. And all of us, we wear white shirts under the sun or black shirt under the sun. We get much hotter if our shirt is black. That's albedo. We are all scientists in this point of view. But many people, they really don't relate to this. So this is the infographic that the students also put together. One thing also that we did with my students, so we were scientists playing with videos, we put together this experiment in which we really doped the ice with black stuff or blue stuff, and we had a room that was shooting 4,000 watts, and the temperature was the same. And so we were filming, doing time lapse of what is happening, which one is melting faster. And this was all projected over in the exhibit and surrounded by soundscapes, so that the people who were assisting and sitting there, they really were completely surrounded by the kind of information we were trying to deliver. And of course, the black part of the ice is melting much faster than the blue. For your information, the black part is not really original apart from Greenland, but it's coffee mixed with ice. So we tried different things. Nutella doesn't work very well, but it's actually more tasteful when you lick the ice. But so this was a video game that we put together, and again, we wanted to focus on processes. We really think that you can treat people like 5-year-old kids. You can tell them even complicated words, complicated concepts. You don't know what kind of things they're grasping. And so we wanted to teach more. It's true that you have more, warmer air, you have more melting, that's it. But you have warmer air, you also start creating, let me stop this for a second. You also start creating these processes. More melting, it makes the ice older, and older ice is actually darker, which means that it absorbs more solar radiation. The sun is really the major driver of our climate. It really delivers a huge amount of energy. And so when these processes start, it's like a self-feeding mechanism. It's like a cannibal, feeding itself on its own melting. And it's like a train going down a hill while putting more gas and pushing it down. So what we wanted to do is really, you click on the clouds, and then if you click enough and it's cold enough, you will have snow. So you're building the ice sheet. And then, you have to balance between the temperature, the ice sheet is there, how much solar radiation is coming, and all the formula equations come from, they are simplified science equations regulating the temperature and the cloud and the solar radiation. But if you come summer and you try to mask the solar radiation, you click too hard, then you generate rain rather than snow. And then the rain really starts melting your ice. And if you have too much melting, what happens is that you're basically going to flood New York City. So it's really, I live on the high side, so it's fine. So this was really the idea of teaching processes through the game. And all this material you can find on the web, including what is my last, I'm going to put down a little bit of volume because it can be loud. I think somebody was sitting in the audience say, and music to me is not music, it's information. And I think I was watching his video recently. So we created also these soundscapes and sonifications. The idea was, how do we translate data into sounds so that we can keep the original content, the original information, but still we try to give it some aesthetic. So these are a sonification and some of the instructions that were provided to us by our John Pearl. And so you will really see, this is like a shortcut, but it was a large and complex process to put things together the selection of the instruments, the techniques used. There is a really full school behind this. So these are the years where you have a very low melting. So in 92 is mountain tube eruption, no melting at all. Slow. And then you have the 2000, where melting is much more robust, and it grows and grows over the last years. So this is what I have. You know, it was like a great experiment for us. I'm really excited that we could put it together. The idea of communicating processes beside communicating, visualizing the data, and communicating their processes through visualization is extremely important, because in this way we deliver not just the data itself, we deliver the information. And then by delivering information, we can really start and create knowledge. And this has to come from a collaboration between the scientists, to my opinion, and designers or data scientists. What we learned, our learning experience was, we had sessions where I was teaching my peer colleagues what are the equations, what are the processes behind, and they were teaching me how a space between two letters can be as important as writing the two letters in terms of design. So all these things are interconnected. But I'm very grateful to Katie and whoever has been patient to listen to this, and I'm very much willing to get any question after the moderator question and answer starts with DJ Spooky here. And thank you very much.
Okay, that was awesome. Thank you. And then we have one final speaker. So please welcome Gavin Schmidt. And we're very happy to have you visiting from NASA. So,
hi. Thank you very much. Okay, that's it. Yes, so I come from NASA, which is the agency with the nice logo. What I do mainly is earth science, climate modeling, trying to understand why climate is changing now, why it changed in the past, what it's going to do in the future. And one of the things that you immediately realize once you start to get into that topic is that this situation is complex. There's a lot of different moving parts. It's very dynamic. It's a global problem. And there's lots of different variables. So the three kind of keywords I pulled out for what I'm going to show you are really those kind of concepts of a dynamic system, a global system, and a multivariate system. And when you're thinking about visualizations, right, it just blows me away how often we don't use any of that information in trying to visualize something. But what I'm going to show you now are 4 examples of some great visualizations that have been put together by the Scientific Visualization Studio at the Goddard Space Flight Center, which really kind of embrace those themes. And I think they therefore kind of stand as great examples for the kind of things that we can be doing. So the first one I'll show you is Antarctica. I went to Antarctica as well, you know, yes. Yes, I spent a New Year's Eve there in 2001. Let me tell you, it was not very exciting. The most exciting thing we did was they have expired flares, which expire at the end of the year. And so instead of fireworks, we'd just set off these flares just for fun. But they're actually quite dangerous, and I set my jumper on fire. But it was a dry New Year's Eve because it was on an American ship. just off the Mertz Glacier, which is right down at the bottom, just down there. But I'm going to show you this animation because it has a lot of different aspects. So what you're seeing there is the seasonal sea ice kind of moving in and out. That's like it comes and goes. And then these lines here, this is in the ice sheet itself, and it's how fast the ice is moving into, this is the Ross ice shelf. But the key thing that this animation was designed to bring out was this map underneath it, right? Which is just a static map, which is a map of the bedrock underneath the ice sheet, right? So we're getting much better data about this than we used to have. And you can see, this is topography that hasn't seen the open air for, maybe 15, 20 million years. And there are key areas here. This is Pine Island Bay, where there's a glacier here. This is the Pine Island Glacier. This is the Thwaites Glacier. These are the places where ice loss in West Antarctica is proceeding so fast. It's just absolutely astounding. But understanding what happens there requires us to know what that bedrock is looking like. What's underneath the ice. And we didn't know what it was. And so it was very difficult to know how the ice was moving, why it was moving. And so we've set up this project, IceBridge, to measure with ground-penetrating radar all of this information. And you can see it's static information, but the visualization has made it extremely dynamic. I'll give you another example, right? More of one that's actually a change in time. You've all heard of the Mauna Loa carbon dioxide record of Hawaii, and we know that that's been increasing year after year after year, right? And you can see this graph here is the breathing in and out of the plants in the season, and then the colors are, so when it's dark, that's when you're breathing out. That's the summertime, and then it sucks in the carbon dioxide to create the biomass the next year. But every year, it's higher than it was the year before, and so we can combine time changes with spatial changes and the complexity that you see. Of course, like where we are now, this only went to 2010. We're already here at about 400 ppm. So this just keeps on going. So good work opportunities there for us all. And then there are things that are obviously more dynamic, right? So wind patterns. We've been talking a lot about the polar vortex recently. Well, this is the polar vortex here. See this is the peak jet stream, and you can see these kind of wavy parts. This is during the summertime, so it's not quite as dramatic as during the winter. But you can see these big meanders. That's what happens. When you're in the middle of that dip there, that's very cold air that's coming from the Arctic. And when it's moving to the north, then this is a very warm area. And so that would be a very high temperature, particularly during the summertime. And you can see that there's a lot of dynamism and inventive graphics that you can do with that. And I'm going to leave you with one final animation that really demonstrates how much you can layer the information. So there's something like 10 different climate fields in this animation. Okay, so this orange, this is dust in the lower atmosphere. These blue, that's a hurricane there. You can see it's just about to make landfall on Florida. This green is organic aerosols coming from either fires, which are in the red. You can see the fires. The white is sulfate pollution from the burning of coal, and that produces sulfur dioxide, which turns into sulfates and acid rain. And you can see that in different places of the world, these different aerosols, like these little particles in the atmosphere, are different. This is dust coming off the Arabian desert. Here you can see pollution off China, right? All this white stuff here, that's the smog in China. Biomass burning here in Indonesia, and all these little red dots, those are fires. And then you've got some of the huge typhoons that occur in the Pacific. And this blue stuff is sea salt. So when you have a lot of wind, you bring up a lot of salt from the atmosphere, from the ocean, and you can see these beautiful kind of low pressure systems. This is the equivalent polar vortex, but around Antarctica, right? And you can see this really fabulous, dynamic picture of all the things going on. The vortices turning around, dissipating. It's just, you can watch this for hours. And you can tell a story with this, right? There are events that are going on here, the fires, the hurricanes, and you're just about to see something else go off just here, boom. That's actually a volcano erupting, and that's the amount of sulfur dioxide and sulfates that are coming from that volcano, and you can see that dissipating over the next few days. And coming back, this is burning in the Sahel, which is a seasonal thing that's done for crop rotation, but it produces this kind of enormous amount of organic carbon and black carbon in the atmosphere. You can see these fires, you can see these beautiful winter vortices coming out and the pollution that goes with that. You have so much information that is available to you. All of this is open source. All of this is available. Not all of it is particularly easy to use, but this information is there. It can be used, and we can layer it in ways that are, I think, enormously captivating. And you end up with animations that can both tell stories, look great, and be true to the science that underlies them. So that's all I had.
Boy, that is compelling, and also, as Gavin said, really interesting to look at. And I think I really love these presentations. Once again, thank you so much for the presentations from our speakers. I'll give them one more round of applause here. It's interesting. I think that we're starting to see more and more of this type of content that I actually think is compelling to a wider audience outside of the communities and the academics that study this, which I think is hugely important, and I think it's one of those things that actually helps expedite understanding, and that's one of the most important parts about this for generations to come. So, super proud of what we've seen here tonight, and we're not quite done yet. I'd like to introduce one more person, and that is DJ Spooky, and a close friend of ours at Vizzualized. He hosted the event last year, our first event, and he was amazing. And he also just got off a plane, I think. So we're happy to have him. So give him a warm round of applause as well. I'm going to clean up my mess that I've made up here for you guys.
By the way, last time I saw Eric, he had a different haircut. And I think this is the Duck Dynasty remix. One of the things about Visualize, and I think that Eric's vision is kind of helping manifest, is that data is not dead. It's a living and very vibrant material that is moving in so many different directions. It's the new palette of our era. So what I wanted to do today is just begin from a personal point of view of, I'm just pulling up here a Google Plus thing here. And one of the things that really blew my mind over the last couple months since I've seen Eric and his crew from the folks from Texas is the Snowden incident. Snowden is considered to be one of the more important revelations post-WikiLeaks. And we have to think about data and the way we generate data and the way the stories that we tell with the data come home to roost. So I spent this morning visiting the NSA. It was quite an interesting trip. And the NSA, we met with the head archivist of the NSA. And nice guy, interesting folks. And it was quite a compelling situation because essentially what ended up happening was they have every device the U.S. military has taken from different wars. Right here you're seeing the beginning or the origins of computing. This is called the Enigma device. Now, during World War II, there was a war, physical war, but there was also a war of data. And what ended up happening is Alan Turing, who's probably considered to be the godfather of modern computing, was needed to help crack the code of the Enigma device. And one of my all-time favorite science fiction writers, Neil Stephenson, wrote a book called The Cryptonomicon. If you haven't read it, highly recommend it. So I was getting a tour through this museum, and by the way, there is not a soul there. It's like totally empty. And the historian was like, yeah, women were involved in early computing, and this is one of America's first massive encryption breaking machines. They were called Waves. The Navy Waves, WAVA. It was women. I forget the other acronym, but it was quite interesting situation. You're getting a tour of this museum of early supercomputing, and you're next to this huge glass cube, and there's nobody. It's just a whole bunch of computers. And so the guy was walking me through the museum, and it was eerie. I mean, it was pretty intense, but also just I'll show you their logo. And if you ever have a free afternoon, there's nobody there. It's you'll have a quiet and interesting place to chill out. There's another museum in DC, the Walter Reed Medical Museum, which has the history of the U.S. military's bullets. If you ever want to see how much our tax dollars at work. So, long story short, data is the new palette. That's something that we're going to riff on in a moment. But I want everyone to kind of think about this from the viewpoint of some of the issues that we were looking at earlier, whether it be Gavin's critique of using the portraits that he was creating of the data versus Marco versus Andrew. Everyone here tonight was looking at a robust engagement with a medium that is essentially about a new kind of literacy. So what we're going to do tonight, and I'm hoping to provoke and invoke with the panelists, is saying, let's look at this as a platform about a new kind of dialectics. If you think about the 19th and 20th century, the moving away from physical goods, the moving away into these frames of reference made of pure information, is how we define modern life. So if I can, I'd love to ask my fellow panelists to come on up, and we will kind of jump into it. And definitely, I'm hoping we get into a nice, robust discussion, because these guys are amazing. And by the way, I think we're the only panel in New York tonight that's all been to Antarctica. So you guys want to come on up? So because we have such an incredible, kind of, I think, brilliant collection of minds on stage tonight, and I just want to ask, Noah's met, me and Gavin have met, Marco we've sort of met earlier, but the other folks I think, have you guys all met before? Or tonight it was just the unified data? That's it.
Well, before like an hour ago. But with Gavin, yes, we worked together.
Oh.
Thanks.
And we haven't been.
There you go.
And we haven't been to Antarctica.
You should go. It's cool.
Yeah, please,
Cold,
yeah,
in fact.
definitely want
Three out of 5. But what I want to do at the beginning of this dialogue is say, what led you guys to the path of data? Obviously, it's a tool used for research, no question about it. But it's something that is not normally viewed as accessible. People think of it as a tool of science, a tool of something that's at the outskirts of the norms of how people think about telling a story. But what I'd love to do is just kind of use that as a touch point to say what attracted you to that kind of alchemy. What made you pull that into a different frame of perspective? Because most scientists would want a very specific kind of roster of how they would present work. And we're seeing a transition now. Yeah.
Why should I start? I don't know. But anyway, so I think data I'm trained as an electronic engineer. So I took my PhD in physics, and then I started to work looking at the Earth. So the only thing that I can see a common denominator in all this, to me, it's data. So I think data for me was really the common path, or what drove me. It was either the output from a model, or the data I collect from Antarctica, or the results from looking at the circuits. What I interpret data for me is really the food for my for what I really trying to do, and I strive to understand, I was saying, the processes. It's more like studying social dynamics or studying climate dynamics. So it's really the data. If you don't take care of it, it gets rotten. If you don't put it in the fridge and save it or you cook it properly, it's not tasting good. You can buy cheap data, but it's not gonna get you as high as good data. So that's basically my philosophy for data. So
Okay,
now it's your turn.
Okay, can I put it on record that we do not cook our data? Oh dear. Science is all about data compression, right? If you think about the enormous amounts of things that you could be measuring, that you could be understanding, trying to condense it down into something that fits on a page, that gets you a paper, that gets you like a graphic on in a journal, or that gets you a job, it's all about data compression. And back in the day, the amount of data that you needed to compress wasn't that large, right? And so you could compress it, and you could have it on one static graph with a line or two, and that would be what you did. If you look at any of Feynman's science papers, the amount of data in those is very small. It's like one or two graphs, a few data points. And yet he was able to condense something very, very profound from the few data points that he had. But today, it's a whole new story, right? The amount of data that was generated by the Large Hadron Collider in order to find the Higgs boson is something like as large as the entire Google database, like 5 times over. And they threw away most of that data, and they only kept a very, very small fraction. The amount of data that we're bringing down from satellites that are orbiting the Earth, from weather models that are kind of producing the maps that you see on every day, from climate simulations, not just of this century, but the next century and back 1,000 years or more, we are talking petabytes and petabytes and soon exabytes of data. Our ability to just compress that down into something that looks like a very small graph is pitiful. And we are desperately challenged by that. Now, the reason why I've started thinking a lot more about this is because, I've been giving public talks about climate change for a long time. And when I started off, I gave very sciencey talks, right? Lots of words, lots of graphs, and, a little bit of explanation. And these went over okay, not brilliantly. And then I started to get better. I started hanging out with photographers and people who had more of a visual eye, and they started saying, "Well, no, you can tell better stories. You can use images." And so I started swapping out my graphs for imagery, and dynamic imagery, right? So the difference between showing somebody how the temperatures have changed on the planet by showing them a graph going up, right? And then you swap it out for pictures of before and after glaciers from 100 years ago to today, the difference in the response that the audience has is palpable, right? People gasp when they see the changes that have gone on. Nobody ever gasped when I showed them a picture of, the GISS temperature series. And so it's really all about that. It's trying to get people to gasp.
Okay.
Yeah. So I was actually a biologist previously, and I was first an epidemiologist, and I started working on the spread of influenza. And one of the very first things that we did is we had a phylogenetic tree. So it's basically a relationship of all the flu strains that we were looking at. And I said, well, we have all the locations where these occurrences happen. Wouldn't it be really neat if we could see that on a map? And I sealed my fate for the next 10 years. And I put a phylogenetic tree over Google Earth. And this was 2006. And so it actually generated that same sort of effect. People, and you could press play over the time, and you could see how the spread of this, it was H5N1 too. So we were in the sort of the echo of that being a scare. And so people were really interested in how this spread and what species were spreading it and how the different leaps between populations were happening. And then I continued my studies as a biologist, always keeping mapping and data visualization there as a way to boil down what was really in the data, what I really needed to communicate. How could I make it more interesting to more people, at the same time keeping some of the scientific integrity and keeping the actual meaning of the data. And then I sort of transitioned and became more of a visualization guy, and now I'm sort of a zombie that goes around looking for interesting data that I can put on a map and make a neat visualization with to show how we can do visualization different and new and keep progressing that field. And so, yeah, I have an umbilical cord that is very tight to data, I think.
Right. So, yeah, in my case, I also used to be a scientist working also mainly on biodiversity. And my first kind of like really got into visualization was when I tried to display on the map every species on Earth. And when you actually manage and you visualize it, it's very powerful. It's like this discovery of suddenly you get the power of, you know, just seeing something that was just like in the database really hidden into data that you couldn't really see. So that was the real beginning. I think like even more than just going from at the same time, you know, there was also this big revolution that we could see on what they were calling mass apps of on internet. So it's not only, you know, where you could do you could do a movie, but you could actually interact with the data. So you could actually represent large amounts of data, and then you could actually customize that experience to yourself. Like, I'm really interested in what is happening here for whatever reason, but my own reason, and try to kind of like get these stories and this data to kind of like closer to the persons. So not only just displaying the data, but enabling people to actually kind of like customize it for their own experience. I think that's what really, I mean, at least from my point of view, got really attract me into the field. The other thing that I was like I guess this is a very similar effect probably we have all that comes from the scientific world is this feeling of reading scientific papers and seeing like very interesting data that was very inaccessible. And when you wanted to kind of like communicate it with your friends, your family, it's just really not accessible. And then you start like really thinking like, how can I explain this? And data visualization was really it was a way that actually could help to simplify things and tell that story. And so this is a little bit like, I mean, Andrew was telling a little bit when we started with the company, was a lot, how can we bridge this gap that is between scientists and the general public? And we think that, you know, like data visualization is this great opportunity because it really provides you a tool that actually can build the stories and also like customize it to each person so that, you know, they can make it more on their own story. I think that's what, I mean, at least what really bring me into this field.
Okay. I mean, the thing that we have now in the post-Snowden era, we've realized that stories matter, and they matter in an incredibly powerful way to catalyze people. And one of the things that intrigues me right now is I didn't watch the Super Bowl. I had no intention of watching the Super Bowl. But I watched O'Reilly and Obama's debate before the Super Bowl, which is quite interesting. That was the Super Bowl for me. And I was intrigued with the fact that you don't have a situation where people are arguing about facts. It's about emotions, it's about ideologies, and above all, it's about how they frame the situation. So the Republicans were arguing about the numbers of healthcare, for example, and saying that that would create a problem with jobs, or this or that, all of which was demonstrably false if you look at Paul Krugman do the number crunching after the Bill O'Reilly. If you haven't read Paul Krugman or Silver over at the New York Times, they're brilliant at breaking down this kind of stuff. So what I'd like to ask for you guys is what makes it emotional? Because I think we're in an era where climate change is one of the most important things facing humanity, but we still have a right-wing agenda funded at much bigger budgets than anybody on this stage by the Koch brothers or whatever. And we're not arguing about numbers anymore. The numbers speak. But the next step is how do we make that have emotional power? And I'd love to just maybe riff on that for a moment and see if you guys have other inspirations or things that you're in the near future or current projects that inspire you.
That actually reminds me. I mean, there was display on one of the presentations about like, you know, like sea rise, no? So it's the typical kind of like effect that is very linked to climate change. And one of the things that we were experimenting there to actually make it closer and to, you know, to bring the emotion. So there's all these discussions about how different scenarios of the reduction of, you know, the CO2 and so on that we put into the atmosphere, you know, what would be the repercussions of this. And we wanted to work on how we could making people to understand. So if we agree to reduce by this level, what will happen? If we agree by this level, what will happen? And kind of like the ideas that we were having is, for example, like we did the visualization where not only will show the places that will actually get flooded, in some scenarios, but also, start getting pictures from people. So saying like this bit is fantastic, well, that's going to be gone on this type of a scenario. So trying to link it more to that type of particular scenarios. I think these are the things that you really need to engage on some of these matters. So that's some of the ideas that we have in. Now, the reality in some of these things is that it's very easy. I think you mentioned it very well at the last of your presentation at the end, is that it's complicated sometimes to make the balance between being scientifically correct and and going very into emotions, because climate and it's very hard. It's a very complex system. So there is not like if I do this, it's going to happen that. No, we know the trends, we know these things, but it's not like if you do this, then boom. And people love that, and it's very easy to tend to try to make visualization that way. So it's I think it's something that you really have to keep in mind, and we always try to do it on this type of visualizations. But sometimes it's a very big trade-off you have to do there, because you have to be honest. And the reality is, like, a lot of times you really don't know, so you cannot make it just as simple as that on some of these situations. So I say yes. I mean, we always try, but I mean, like, I don't know how the others find it, but sometimes it's a little bit of a challenge to actually not jump into kind of like,
Well, let's put it this way. Like, just the other night, between O'Reilly and Obama versus also Bill Nye, a.k.a. the science guy, and Ken Ham, this creationist who did this Museum of Creationism. It's kind of an amazing thing where you have some people saying very clear, very succinct facts, and the other person is like in a whole different quantum reality, So they were like, the world's made in 7 days. What are you talking about? And try saying that in China, and they're like, well, or 6 days. Sorry, when God rested on the 7th, right? And if you're talking about debating environmental issues with those kind of people, it's like, what are you going to say? God made the world green, but what, we're going to burn it anyway. So something. How do you? I mean, so what I'm hearing, what you're talking about is distilling the complexity into something that is easy to digest, but on the other hand, beautiful. And that's what I think you guys have been doing. So let's continue. I mean, what do you think?
Yeah, I guess I think about that quite a lot, and just continuing, I guess, what he said, I think a lot of it is making somebody be able to look at something and see how it relates to their world. And so whether you show somebody a visualization, you have to hold their hand from the sort of global view to their local view and show them how it connects along each step of the way, or you show them something that is directly apparent in front of their face that it is related to their world, whether that is something on the scale of the things that they know. Like you keep bringing up the Snowden topic, and so that's an interesting one because a lot of numbers are thrown around, like X million number of people affected, X billion number of text messages collected. Like understanding the scale of that is very, very difficult. And even as somebody who considers himself data literate, understanding the magnitude of those numbers feels impossible a lot of times. And so the same challenges happen with climate change, is that we're talking about things that are very complex, very big, and very hard to just boil down. But the more you can bring it to somebody's world that they understand, the better that we're going to be for making the arguments that we need to change them. I guess I was like, Javi and I were arguing about this before, about how relevant the snowplows were to climate change. And the thing is that, if you say 50% of the people are going to buy the argument and work with us to make things better, and 50% aren't, and we're not meeting them quick enough, if we can also make arguments about things that are just mutually beneficial to fix, that also have good effects on climate change, that's a way to get those arguments into their world around them without changing their mind about the things they disagree with. Just show them how it relates to the world around them and how that we can come up with solutions that are good for all scenarios.
Gavin?
So we process data in multiple different ways, right? If you've gone to grad school and you've had the kind of scientific method literally beaten into you, it takes years to engage with data at a scientific rational level as just without thinking about it. And you see that you see like graduate students, they come in and they're all very keen, but they leave after having had sometimes a tough time, with a very different appreciation of how to do that right now. So if you've got something that takes somebody 5 years to just begin to get the hang of, right? That's not something that you can use in something that you're going to tweet, right? So, well, no, not really. And so what you see is that the way that most people get information or get impressions or come up with opinions about things is it doesn't go through that kind of rational, analytic part of your brain. It goes through the emotional, visual, oral kind of pathways that kind of key into things that are much deeper than your kind of rational kind of type 1 thinking, right? And so imagery connects you to those centers much quicker. Animations, because they're more real, right? Faces connect you to that. Stories about people connect you to that much more than stories about data, right? So if I want to have a discussion with people and there's a suspicion of science in the room, or a suspicion of climate science, and everybody thinks that, oh, maybe you're just doing it for the grant money or something like that. The way to deal with that is not to bash people over the head with the results of the science, but to tell people about the process of the science. Who is that person? Why are they there? What are they doing? What do they think they're doing? Why is it so terrible? Really, what do they think they're doing? And people kind of get drawn into that, and then you build a trust that what you're saying is valid because you're telling people stories that they can relate to, right? So it's not that you're trying to avoid the rational thinking part, but you're trying to find an entrance that will allow them to take the time to think about these things rationally, in the end.
Okay, so building doors that people will want to go through. I mean,
that's good, yeah.
Yeah, Marco.
So going back to the emotional, data and emotions. So there are a couple of things. I think one thing important is data provenance, as we call it, and data quality. You can cite any data provenance, but there are some standards of data quality that you really need to meet in order for data to be trustable. And so you can go back and do all the, say, oh, we rerun that this 8%, 10%, but there's all the philosophy behind. What I think it's really emotional to me personally is and for the data visualization also, is the transnational really. The goes beyond the language barriers, for example, of communicating. One experience is, I work a lot with the Arctic, in the Arctic, and I have Arctic very close to my heart, though I'm from South Italy, but, and there is a little difference. But so, yeah, but the point is that when you go there and you talk to people who live in Greenland, for instance, the Inuit, they don't know what actually is happening. People in North Carolina know more, and a housewife in North Carolina knows more stuff about Greenland melting than the Inuit living there. So you go there with the visualization tool, with a map, and you explain them that the airports now in Greenland, they have maps taken from some of us and scientists who have been working on this and translated into in some of the Inuit language, because there are so many dialects and words and so many words for the same thing, that the visualization of data really creates this, spread the germs of information without, Gavin is laughing, but I'm sorry. Tonight I'm very creative about cooking and diseases.
You're Italian.
Yeah, so like, and so this is, to me, it's very emotional because it really delivers the information to the people who matters. The Snowden case, people now, you talk to them and it's like metadata. Oh, I know it's something that comes up from my cell phone or my laptop when I connect. I don't know exactly what it is, but I know I am doing something that then it's used, and then you start having this participatory process of people, either the Inuit for the climate or other people concerning cell phones, that creates movements and information, and this is powerful. This is extremely powerful. It's not a process that you go from a good food to a broken food in a second. It's really like it takes a process, a step by step. Yeah, and it takes step by step, and you go. And you
How long did it take you to break your leg?
a second.
That's the data.
But and so that's how you do it. It's like little by little, and all what Visualize is doing, I think what Javier and Andrew are doing, it's fantastic because it really creates these seeds and they spread this information. And to me, that's emotional. People think about data as something dry, or it's culturally and historically considered something dry. And I agree with Gavin. You really need to be trained to think in certain ways about data, but that's where the power, I think, of the merging of scientists with, or somebody like their background, scientists with a background in science and moving toward visualization that's the real power.
Okay, so one last question, because we have to wrap up in a moment, but there's other people in climate change who take the opposite point of view, someone like Bjorn Lomborg, who's been doing a lot of stuff funded by oil companies and so on. He did a film recently called Cool It, where he was showing geoengineering and other things, but he would play with the numbers in a way to almost get the exact opposite of everything everyone on the stage is saying. For me, it was intriguing. Like everyone here, I have a feeling we would all agree climate change is happening, and it's a major, heavy situation, and it's probably going to be devastating on a lot of levels. Someone like Bjorn Lomborg would be able to take the same numbers and flip them around and be able to make it say almost the exact opposite, and very clever, very well argued, but eerily twisted. Someone, if you say the glass is half full versus half empty, the data describing that can be 0 or 1, half and half. But when some scientists who would probably be on that other kind of perspective would come into play, I'd love to hear, because this is the last question here, but the ideology of social good. I mean, do you feel that data is a tool to advance things, progress things, or could be easily manipulated? And these are things that, this is an era where people literally can argue exact opposite facts based on the same data set. And I think there's some intrigue around that for the next several years as we move further into a data economy. Just maybe that's a little meta, but if you could just maybe do maybe a 2-minute or 3-minute succinct thing, and then we'll just go from there.
So there are some very smart people, and data is complicated. And in the same way that you can see a rabbit in a cloud, people can see things in the data that just aren't there, and they can make whole careers out of seeing things in the data that aren't there. How do you deal with that, right? Well, when somebody says, "Hey, there's a rabbit in the cloud," right? You say, "Well, no, there isn't, because look." Now it's different, okay? So I just needed a bit more context. And now there's no cloud at all. There's no rabbits in the clouds, right? You just, context, right? A lot of the times when you're hearing these little factoids, they're shorn of context, right? They didn't tell you what the range was, and they picked a number, and then they're totally confident about that. They didn't tell you, they show you a picture that's this large when really the data is that large, and it gives you a very, very different story. So I think the way to gain credibility as a data presenter is to allow people to see that context, to not just give them a little postcard view of what that data is, but allow them to dive in through that view and then expand it out, right? And that is the way to drive out bad information. It's by giving people good information. And there will be people who will want to shrink it down and make it look different to what it is. But you have to, if you're a provider of information, if you're a provider of visualizations, the more that you can go in and provide context, the more trustworthy you become, and the more the conclusions that you draw from that larger context will be credible.
So data is not neutral.
Data, no. Data is completely neutral, right? The stories that we tell
story is not neutral.
Are very personal, and if you want to have a reputation as somebody who tells credible stories, you have to provide that context.
Have you met Bjorn Lomborg? I would be curious to see.
No, I
So,
haven't.
so when you ask the question and then listening to your answer, in my head, it just is the strongest call to open data, transparent methods, and no black boxes in science, right? And if you think about scientific publication, and this is something that scientists are really aware of right now, but for the longest time, journals have been print media. And so you, by the very nature of them, had to reduce the things that you put in them. And so there are a lot of studies that are hard to reproduce from reading the journal article. But in today's age, when journals are being online, or a way to archive data, or a way to archive methods, things are becoming more transparent. And so I think that the data is neutral, knowing the methods that they applied to them, and being able to actually try to reproduce those things is going to drive a lot of this sort of like two sides of the story out. So I think open data and open methodology.
Well, actually, building on that, I truly believe in that. I think this is the way to kind of like mitigate things like climate gate and, you know, like these kind of like scenarios where you, I mean,
Give a little context. The climate gate was when these scientists' computers were hacked, and they were, quote unquote, it was a right wing, some sort of hacker group that wanted to cherry pick the scientists' data to say that they were manipulating the data to show that climate change was happening, but actually it was false. So it threw this huge radioactive cloud over the research. Just, you know.
yeah, oh, right. Sorry, it's just kind of like so. Yeah, so and that was kind of like a very strong example of, you know, when you do things hidden, or, you know, like how transparency can be very powerful to mitigate sometimes, you know, like the views from other groups on doing things like that. But I mean, I believe it's not only, you know, the fact of we need transparency and having open data and so on, but like you're saying, methodologies and be able to access, you know, so people can actually analyze and understand the data by themselves, you know, create visualizations by themselves. I think like this, it was said before, you know, like most of the visualizations you've seen could be created by anybody in this room, but the data is out there, but it's very hard to find. It's very hard to manipulate if you don't know about it. And I think like some of the problems that we are facing is that there is still like scientific data, and then there's a huge gap, you know, between, you know, people who actually can visualize it, and there's only a few people in between that can play this middle ground. I think what we're missing is, you know, is more kind of like, you know, more layers. We need to have some sort of Earth API. We need to be able to, we need to, I mean, like, it's the same like with Wall Street. It's supposedly everybody should have access to the same information and should be able to do their own analysis. But right now, we're still like on the hands of people to tell us what is happening, and then it's way easier. But and the reality is, because it's complex data and because there's not enough literacy on working with this data, I think what we need is to have a full economy where there's like these different layers of people transforming the data so it becomes accessible and it's less manipulable, because, you know, it's just being treated by more people.
Totally. So last comment, Marco?
I just give me 30 seconds. So building on you, I mean, I think that you can change time is money and data is money, really. I think that time has come. And what do you would say to somebody like Bjorn? I mean, in the past, somebody said, oh, look, it's the Earth rotating around the sun. The Earth is not flat. There were still people saying the opposite. So they'll fade away eventually.
Galileo.
Well, science, you know, they'll fade away. So that's my approach. And I think continuing spreading the germs. It's extremely important. That's, I don't want to take any more time. We probably are over time. And I'll give the word to you back.
Okay, so this conversation hopefully will be continued. Everyone here is on Twitter and Facebook, and you were kind enough to show your Twitter feed. In fact, I would love to say that continue the dialogue by tweeting at them, Facebooking, and so on. And tomorrow the conference opens, right? And I think maybe we'll have Eric have a longer beard, a grayer beard, by the end of it. So thanks, guys. I'm Paul Miller, DJ Spooky. Everybody here is presenting, and thanks for coming out tonight.
And I just want to say that we still have some drinks if anybody wants to hang out in the reception area. Very excited to have you all here tonight. I think we're definitely going to continue this conversation. Some very powerful stuff here, and stuff that we, the conference planners, are very much into. And so I think we'll see a lot more of, looking at that logo where it says visualized with a colon and something else after it that is a topic that is very important to us. And I think that's the direction that we very much want to go into. So thanks for being part of this special event. And for those of you that can make it tomorrow, we look forward to see you. And thank you very much to the Visualize 2014 speakers.